Playdoh Circuits by Eli, Emily, and Natalie. For our project, we wanted to gain a deeper understanding of how circuits work. So, our main goal in conducting our experiment was to build a functional circuit using a homemade Playdoh resistor. What I mean by functional is that we wanted the circuit to allow an LED light bulb to light up and an electric motor to work. Initially, we hypothesized that a resistor made out of Playdoh would be good use in our circuit because the salt and water combination Playdoh is made out of has been proven to be a good conductor of electricity. After conducting the experiment, we found that when the resistor, the LED, and the fan were in a parallel circuit, the fan and the LED were functional, and our resistor had a resistance of 44,321 ohms. Some physics concepts that are important to be aware of when conducting this experiment are that a circuit is a closed-loop network in which electrons flow from a battery or other source. It is also important to know the difference between a series and parallel circuit. In a series circuit, the voltage changes while the current flowing through the circuit stays constant, whereas in a parallel circuit, the voltage stays constant and the current flowing through each component varies throughout the circuit. Lastly, in order to find the resistance of the Playdoh resistor, you need to know that resistance equals resistivity times length divided by the cross-sectional area. All these values pertain to the Playdoh resistor we made, as the data from our experiment was used to calculate the resistance of the Playdoh resistor.
For our assumptions, we assumed that the motor that was used in our circuit was limited at 300 milliamps of current in order to spin, so it needed at least 300 milliamps in order to be functional. The LED bulb that was also in the circuit was voltage limited, which required 2 to 3 volts of electricity, but if it received more than 20 milliamps of current, it will burn out the bulb. We also assumed that the Playdoh we used for our resistor has salt in it, which means that it contains both positive and negative ions. And then on top of that, we also assumed that the resistivity value P of Playdoh was 36.39 ohms, and it was correctly calculated via the use of the amp multimeter in the pre-lab.
The materials we used for this experiment were a white LED light bulb, yellow Playdoh, an electric motor fan, 8 alligator clips, 2 metal wires, and 4 batteries that were 1.5 volts each. The LED bulb and electric motor were set up in parallel to each other, and a total of 6 volts was provided by the batteries. The Playdoh was formed into a fun S shape.
For our experimental models, here on the left, we have the system schema, which shows the 6-volt battery, which has electrical energy connection to the Playdoh, the electric motor fan, and the LED bulb. And on the right lower hand side, we have a PhET simulation of our circuit that we created in class for the lab. And above that is the power box of the circuit.
So on the right-hand part of our slide, we have necessary information that was needed to find the resistance of Playdoh. Then on the left-hand side of the slide, we have the calculations that we used to find the resistance of Playdoh. So in conclusion, we found the resistance of Playdoh to be 44,321 ohms.
For our conclusions in this lab, we found that the Playdoh was able to act as a resistor due to its electrical conductor capabilities, which the reason behind this was due to the salt in Playdoh, which allows it to have a transfer of positive and negative ions within the Playdoh in the circuit. The circuit was completed and both the fan and the light were functional with Playdoh as the resistor, showing that our circuit worked. We know that the light bulb received a current smaller than 20 milliamps because it did not burn out and it lit up, while the fan had a current larger than 300 milliamps because it was functional in the circuit. This is due to the difference in the resistance between the two, as well as the Playdoh resistor, which was in the shape of an S, which offset the current throughout the circuit as it was in parallel. And then after our calculations, it was found that our S-shaped Playdoh resistor had 44,321 ohms of resistance.
In terms of experimental flaws, the measurements of our Playdoh resistor could have been off by a little bit. We had to change the size of the Playdoh resistor multiple times before it finally worked, and it took us multiple times for the electric motor fan and the light bulb to work at the same time, until we decided to put them both in parallel. We also neglected to measure the current running through the circuit, so we had to make assumptions when we were making our power box diagram.